Hello and welcome to section 2.3, product and quotient rule and higher derivatives. So this is our first example for today. We're going to find the derivative of this function, and it is a product rule. And just as a reminder of what the product rule is, you're taking the derivative of two functions that are multiplied together, so f of x times g of x. And so basically our product rule says f prime of x g of x plus f of x times g prime of x. And so the book has it in a little bit different order, but this is the same thing. Because we're adding in between, it doesn't really matter. And I believe that when we do the quotient rule, this follows a little bit more closely to what the quotient rule is. So that's why I always do it this way. So if I'm going to go ahead and find this, I'm going to follow this pattern. And so you can see this guy right here would be f of x, and this one would be g of x. So I'm going to go ahead and follow to take the derivative of h of x. So it's h prime of x, and it says take the derivative of f of x. So I take the derivative of this, and just following my power rules, I get 3 minus 4x. And then I'm going to multiply that by the original g of x, which gives me 5 plus 4x. And then I'm going to add on, well, rewriting f of x, which would be 3x minus 2x squared, and then taking the derivative of g of x, which just gives me 4. And so at this point, now it's just a lot of little algebra to go ahead and solve through this. And when I do that, I just get to distribute and multiply it all together. And so that's pretty much what I'm going to do here to simplify this. And on the AP test, if they give you something like this, they may have you simplify it, they may not. It just kind of depends. So we're gonna simplify it just as the algebra practice. So I will get 15 plus 12x minus 20x and minus 16x squared. That's just foiling this. They did first, outside, inside, last, and then I'm going to multiply everything by 4 here, which gives me 12x minus 8x squared. And so now I can combine my like terms, and so h prime of x, I have negative 16 and negative 8x squared, so negative 24x squared, those guys. And I like to kind of cross them out just so I know I've dealt with them. And then I've got 12 and 12x, which gives me another 24x. And oh, oops, and I forgot the negative 20x there, so that's a good thing I was getting ready to cross them out. So I end up with actually 4x. And then, so all my x's have been dealt with, and so then it's plus 15. And so that's really what you're doing when you go ahead and do the product rule. You could multiply this out originally and take the derivative of it, but that's just a lot of extra work for you. So moving along into example 2, we are going to find the derivative of this, and you'll notice that it is x times sine of x, which basically means it is a product rule. And so my f of x is x, and my g of x is sine of x. So if I'm going to take the derivative of this, remember, I'll just write the product rule. Again, the product rule written out is f prime of x, g of x, plus f of x times g prime of x. So now if I follow the product rule, I'm going to say dy dx. When I take the derivative, I take the derivative of x, I just get 1, and then that's times g of x, which is sine of x. And then I will add on, leaving x alone and taking the derivative of g of x, which turns into cosine of x. And so my final derivative for this one is going to be sine x plus x cosine x, and that is what I get when I do my my product rule of this. Moving along to example 3, I end up with this as my derivative. They're asking for the derivative, and this is just a little bit more complicated, but it's still the same thing. Here is the reason why I want to show you this problem is that this right here, the 2x times the cosine of x, is a product rule, f of x, g of x. And because they're both in terms of x. Over here, the 2 sine of x, the 2 doesn't have an x with it, so no product rule necessary. So this part is just a standard derivative, a power rule, or one of our basic differentiation rules, and so there's no product rule for this one. because a product rule is only necessary when you're taking variables times variables. And so there's our x, and we're multiplying it by cosine of x. Here we only have a number, so it's a constant multiple. So when I take the derivative of this thing, and I'll write out the product rule one more time. It's f prime of x, g of x, plus f of x, g prime of x. And so in order to do this first part, I do have to use the product rule. So dy dx will equal, well, f prime of x is the derivative of this, which is just 2, leaving cosine of x alone, adding on, leaving f of x alone, which leaves the 2x, and then taking the derivative of cosine of x will give me negative sine x. And then for this last part, since there's no product rule necessary, I just continue on. The negative 2 is a constant multiple, so I can just go ahead and write the negative 2 and then take the derivative of sine of x, which is cosine of x. So then it's just a matter of simplifying this a little bit, and I will end up with, looks like 4 cosine of x plus, or 4 cosine of x minus 2x sine of x. And then you may see them, wait, what did I do wrong here? Oh, whoops, sorry. It's not that. I added when I should have subtracted. And so you'll notice that I have a positive 2 cosine x and a negative 2 cosine x, so I cancel those guys out. So my final answer for this guy is 2x, negative 2x sine of x. And that's what my derivative is. And remember, derivative is slope of the tangent line. So in my next example, this time I'm gonna have to do a quotient rule because I have a rational function. And so I'm going to write out the quotient rule just to remind you. And so it's asking me to take the derivative, and this is notation for the derivative, of f of x over g of x. And so this comes out to be, and this looks a little bit more like our product rule, f prime of x, g of x, minus f g prime of x, all over g of x squared. And that's the whole thing is squared, not just the x or whatever. It's the whole thing is squared. And g of x can't equal 0. That's the trick to this. So what I've done here is, just to remind you, is that I set up the top part the same way as I did with the product rule. The only difference is it's a subtract sign, and that should make a little sense because when we're dividing, we're subtracting, not adding, like product. So if I go ahead and take the this will be f of x, we'll say, and I'm going to go ahead and take the derivative of this, and this will be g of x, so I can just kind of follow this rule. So if I'm going to take the derivative of this function, dy over dx will give me, well, f of x, f prime of x turns into 5, and so I rewrite g of x, which is x squared plus 1, and then I subtract away f of x this time, which is 5x minus 2, and then multiply by the derivative of g prime, or of g of x, which gives me 2x, and then all of this gets divided by x squared plus 1, the whole thing squared. Now, I wouldn't bother multiplying out the bottom part. You don't really need to multiply out the bottom part. That's just a lot more extra work that you don't need to do. But what I'm going to do is I do need to simplify the top, and that's part of the That's part of the challenge of these. So dy dx, and so I have to distribute my 5, so I'm going to get 5x squared plus 5. And then this guy gets distributed also, which gives me a negative 10x squared and a positive 4x. And so now I can, if I have any like terms, I can combine them together, and the bottom remains the same. If I have any like terms, I can combine them. It looks like I've got 5x squared and a negative 10x squared. So I have a negative 5x squared on top. Those guys have been dealt with. I have plus 4x and plus 5. And so that should be my numerator. And then on the bottom, it's all over the x squared plus 1 squared. And there's a reason why we don't want to multiply out the bottom. We'll use it for other things later on, and so we don't want to multiply out the bottom unless we absolutely have to. So then this next one, we're going to have to do a little bit of work before we get moving along here, before we actually try to find the derivative, because of the way this is written 1 over x, so as a fraction. So the first thing is I would probably write this as try to write this so that we end up with a common denominator or something like that. So I have y equals 3 minus 1 over x, and this is over x plus 5. And so if I multiply by x top and bottom, then this will basically get rid of my fraction, and it's multiplying by 1, so I'm not really changing anything. So on top I've got to multiply both of these guys by x, and on the bottom I'll multiply both of them by x. So I will get a new function that I'm going to use, which means the x times the 3 will give me 3x, and the x times the 1 over x gives me minus 1, and on the bottom it's going to be x times both of these terms, which would be x squared plus 5x. So now I have my two functions, and it just helps simplify this a little bit. And I did this so I could get rid of this fraction. There's other ways to go about this. You could have gotten a common denominator on top, and then you would have moved this bottom part up. It would have gotten you to the same spot. But now that I have this, I have an f of x on top and a g of x on the bottom. So now I could follow my quotient rule, and just a reminder of the quotient rule, it's f prime of x, g of x, minus f of x, g prime of x, all over g of x squared. So following that rule, I'm just going to go ahead and differentiate this. So dy dx will equal f prime, take the derivative of the top, which is 3, times the bottom, which is x squared plus 5x, minus, leave the top alone, 3x minus 1. Derivative of the bottom looks like I get 2x plus 5. And then on the bottom down here, I get a square of the bottom, which is x squared plus 5x squared. So now I have this thing all multiplied out, and it looks like a big mess, which it kind of is, but I have to distribute and simplify this, and so that's what I'm going to do. And so dy dx will give me, if I multiply both of these guys by 3, I get 3x squared plus 15x. And then now I got to FOIL this together, so I'm going to take 3 times this and 3 times that and that, multiply them together, so 3x. So, and I'm going to use the negative with it, so I'm going to get a negative 6x squared will be the first term, and then a negative 15x for the next term. For the inside, I have two negatives, which is positive, so I get a positive 2x. And then my last term, I get a positive 5. Sorry, I about went off the page there. And all of this is over x squared plus 5x squared. See if I can move this over a little bit. Oh, I can a little bit. There you go. And so then finally, when I just have to combine my like terms, and so my final answer is going to be dy dx equals, and I'm going to write the denominator first, just get that out of the way. And so the top, if I combine like terms, I have, looks like a negative 3x squared. That'll take care of those guys. I have a positive 15x, a negative 15x, and a positive 2x, so it looks like 2x. And then the only thing left is the 5. And so that's basically what ends up happening when I simplify this, and that's the derivative of this example. So that is part 1 of these. I have a couple more examples to do that I will continue on with part 2, so please follow along into the next examples. Thank you.